Okay, so let's continue with gradient, divergence, and curl. So these are special vector operations. Okay, so this is a differential operators, which is actually a vector. Okay, so you have the first partial derivative with respect to x, the operator for the first partial derivative with respect to y. This is for partial derivative with respect to z. The gradient is defined as follows. So this is the symbol. Okay, given a function that has continuous partial derivatives. So the gradient is obtained by getting, the first partial derivatives with respect to x, with respect to y, with respect to z. And then for the divergence, that is applying the dot product between the operator, okay, the first partial derivative operators, and then vector A. So this is actually a vector, okay, and note that taking the dot product, or the dot product between these two vectors is obtained by taking the sum, no, of the products of the respective components. So this is or this expression is equal to the first partial derivative with respect to x of the x component of A. This is for the y component and then for the z component. So the next one is the curl of vector A. Okay. So that is the cross product. The curl is the cross product. Okay, so you have the components of your differential operator, and then the components of A, and then the orthogonal unit vectors. Okay, assuming that vector A has continuous first partial derivatives. Okay, so let's have an example involving those special operations. So you're given the function phi, okay, and then your vector A with the following components. So we find the following operations, starting with gradient phi. Okay, so phi is x cubed z squared e to the y. Okay, so we get the first partial derivative with respect to x. So z squared and ey are constant, and then derivative of x cubed is 3x squared. Okay, now for the second term, we differentiate phi with respect to y. So therefore, x cubed and z squared are constant, so we just copy. Derivative of e to the y is e to the y. And for the third component, we differentiate with respect to z. So x cubed and e to the y, okay, are constant, so just copy. Derivative of z squared is 2z. So this is your grad phi, or gradient of phi. And then given A, what is the divergence? Okay, so that is simply the dot product. So we multiply d over dx by x e to the z, or a to the x, and then d over dy times ay, d over dz times az. Okay, so the partial derivative of, okay, x e to the z with respect to x. So just copy derivative of x is 1. Okay. And then derivative of xy squared or negative xy squared with respect to y. So negative x is constant, copy derivative of y squared is 2y. And then with respect to z, 3x squared is constant, derivative of z is 1. So take note that this is a scalar product, so you get a scalar function. Okay, for the curl, okay, so that is cross product between the differential operator and vector A. Okay, so you have the first row, the components of the D operators, so differential operators, and then the components of A. Okay, and then the orthogonal unit vector. So starting from here, okay, so positive, delete. Now product of this is obtained by taking the partial derivative with respect to z. So this is a pure constant. Okay, if you differentiate this with respect to y, x and z are treated as constant. So since this is a pure constant, the derivative will be 0. With respect to z, negative xy squared is also a pure constant, so the derivative will be 0. So for negative j, okay, negative j, so delete. So the partial derivative of this, okay, with respect to x, okay, so is 3z, then derivative of x squared is 2x, so you get 6xz. And then derivative with respect to z, so x is constant, derivative e to the z is e to the z. Okay, and you have a negative sign here. Now for k, so delete, then derivative with respect to x, so x is 1, derivative of x is 1, and then you have negative y squared, and then delete, so negative of the product, so take the derivative of this with respect to y, but this is a pure constant, no y here, so the derivative will be 0, and then just simplify. Okay, you get, okay, the cross product of the operator and a.